Okay, so now that we've established how the atmosphere circulates, both with respect to air and water, really, we can move into ocean circulation because the ocean responds largely to the atmosphere, as we learned, right? And so on the figure to the left there, similarly shown down on the first slide of the ocean circulation section of the PowerPoint, we have the trade winds and the westerlies indicated by these red arrows or pink arrows over on the iPad. And those dominant wind currents are going to exert a frictional force on the surface of the oceans, right? And so that wind, just like blowing across the surface of water in a drinking glass, the wind is going to set the surface of the water into motion. Okay, and that's going to mostly create the currents that we see, right? And so if we go to the next slide, or a couple slides later in the PowerPoint, the trade winds there are shown with green arrows and the westerlies with red arrows, as the little key indicates. But you can see that the surface ocean currents, they're indicated as warm currents and cool currents here. The surface ocean currents generally just follow those patterns. We have these things called gyres, these just large circulating kind of spiraling masses of water in the northern Atlantic, the southern Atlantic, the South Pacific going that direction, and the North Pacific going this direction. And if you look at them, you can see that in the northern hemisphere we have clockwise circulation patterns, right? Currents generally deflect to the right of their direction. It just continuously deflects to the right, creating clockwise circulation. In the southern hemisphere, it's counterclockwise because the Coriolis effect is what's really driving this. Also, with oceans, you have continents, and so the ocean currents, like these equatorial currents here, they run into a continent and they have nowhere else to go. But they could go north or south, but they don't. The ones in the northern hemisphere generally stay in the northern hemisphere. They deflect to the right because of the Coriolis effect, right? And similarly to the left in the southern hemisphere. And so on the iPad here, we can draw these in, right? So there are the circulation patterns, and I've color coded the arrows on there so that you can see warm air, or warm water rather, is being transported from the subtropics to higher latitudes, right? So in the South Atlantic, water is coming across the equator, being sort of driven along by the trade winds, kind of coming from equatorial Africa over across the Atlantic towards equatorial South America, right? And north of the equator, that bends to the north, okay, it deflects to the right, creating what we call the Gulf Stream, which takes warm water up the east side of North America and then carries it off into the North Atlantic, up toward Greenland. In the South Atlantic, we have an equatorial current that's flowing from east to west, and when it hits South America, it deflects to the left, to the south, carrying warm water to higher latitude. Those gyres circle back, and as that water cools, it dumps its heat into the environment in the higher latitudes. It circles around the ocean basin and comes back toward the equator, right, in these eastern boundary currents. And so it just cycles in this gyre, okay, and it transports a lot of water, a lot of other important things around the Earth's surface, but it transports heat. And for the sake of this discussion, we started with the global energy balance, or maybe more specifically, the global energy imbalance. And what we said is that drives circulation, right? We're trying to reconcile this surplus of energy in the subtropics and this deficit of energy at high latitude. And we reconcile that through circulation of the atmosphere and circulation of the ocean, right? Yeah, warm water currents take warm water from equatorial latitudes to higher latitudes, and cool water currents bring it back. Okay, and so we can look at the Atlantic, and you can see part of the Indian Ocean there. We could switch this over. Let's see, where is that on this iPad? Oh, we've got all of the circulation there. Here we go. Okay, so that's the Pacific, right? it looks almost identical. It's just a much, much larger ocean basin. We have a counterclockwise gyre in the southern hemisphere, in the South Pacific, and we have a clockwise gyre in the North Pacific. The equatorial currents carry warm water that gets warmer and warmer as it traverses the the subtropics, and then it goes up the western boundary of the ocean basin to the north in the northern hemisphere, carrying warm water to high latitude, and the opposite in the southern hemisphere. And so it's all about carrying energy, heat energy around the Earth's surface and trying to redistribute it to balance out this the colors that I still have on the iPad there, right? The surface of the Earth is warmer in the subtropics than it is at the poles. That is intuitive. We all know that, but we've now learned why, and we've also learned how that drives circulation as a result. Okay, so the next video is going to move on from that into deep ocean circulation and sort of the structure of the oceans, which is really important to all kinds of things. But we'll explore that next.